All right, kiddos, this is the Unit 8 test review. So before we get into it, let's take a look at all of the equations and things that that probably are super uber important in this chapter. All right, so we first begin with problems in which they provide you a sigma. So when they give you a sigma, you need to be able to come up with your ZC, with your error factor, I'm sorry, E, that is ZC sigma divided by the square root of n. So we have this equation that we have to get. Again, you get that ZC from the table, and again, that is dependent upon the confidence that you particularly have. All right, so there's that equation right there. So again, the ZC comes from the confidence. And then from there, the confidence interval that you're going to be establishing is x bar minus E, and this is predicting what the actual mu is to x bar plus E. All right, so there's that setup right there. Next, we started talking about if they provide you with an S. So in that situation, E is equal to TC S divided by the root of n. All right, so TC, you're going to obviously depend upon the confidence, and also a degree of freedom, which again we estimate as n minus 1. That is required in getting that TC. But as soon as you develop that, then your confidence interval, again, is the exact same thing as above. It's predicting the population average. And then the third type of problem that we're going to be establishing is when we have some sort of probability. Okay, we have a probability involved. So a couple different formulas here. The probability itself is estimated as being the number of successes over the number of things in your sample. And again, Q hat is opposite P hat, such. And then here we go. We have the error, and that's going to be ZC. Again, you get that from the Z table and the confidence that you have. And then you have P hat, Q hat divided by N rooted as such. And then the confidence interval that you're establishing is you take the sample minus E. And again, this is predicting P, not mu, a probability, the actual probability, to P hat plus E. All right, so there's that involved right now. And then the last but not least type of question that you're going to be facing is what is the minimal sample size? And so the minimal sample size is going to be if you have no preliminary estimate. That means if you don't have a preliminary estimate, you have no idea what the probability should be. You have no idea what the probability should be. And if that's the case, the minimal sample size is going to be 1/4 ZC divided by E squared. Okay, so again, the ZC comes from the confidence. So the confidence, in essence, is going to tell you what the ZC is. And then they'll say a distance from mu. A distance from mu is what the error is. So that's that kind of concept. And then if they do give you a preliminary estimate, let me scroll down here. They do give you a preliminary estimate. All right, then your minimal sample size is going to be the probability times the failure of ZC divided by E squared. Okay, so what should the probability be? So there's all of that. And now the last thing that I kind of want to talk to you about is just general mathematics. So if I have an answer equal to something, and let's say this is A times B divided by C or something like that. Okay, what I recognize out of this mix is, let's get a different color here. Let's go with that color. That A is a multiplication number. Let me go a little bit darker than that so you can see it better. A is a multiplication number. B is a multiplication number. C is a division number. So how does this affect the answer? If you're multiplying by something, it's going to have the same result. It's called a direct relationship. Okay, so if I multiply by a big number, my answer is going to get big. If I multiply by a small number, my answer is going to get small. And then division is the opposite. It's called an inverse relationship. So if I divide by a big number, I'm going to get a small answer. If I divide by a small number, I'm going to get a big answer. All right, so there's these concepts that you have to also understand in this chapter. So here are the things and the formulas that you need to know. Okay, let's go ahead and get to work. All right, and problem number one, this is a sigma problem. So they give me an average of 27.3, standard deviation of 3.1, a sample size of 23 dogs, and I have a confidence of 85%. Okay, because I know where this is headed, this confidence is going to tell me that my ZC, again, you got to go to that Z table and take a look at that little box, and 85% is 1.44. 85% is 1.44. Okay, so I have that right there. So now I go ahead and establish my margin of error, my E in this case. So E is equal to ZC sigma divided by the root of n. So this is going to be 1.44 sigma divided by the root of n. And so this E in this particular problem is 0.9308. All right, that is my E in this particular problem. And so last but not least is the confidence interval itself, which is x bar minus E is less than mu is less than x bar plus E. The middle stays the same, and I just get the answers to the side. So x bar minus E and then x bar plus E. All right, so nice, play it twice. We have a confidence interval We do not have the average of this sample, so let's go ahead and find the average of this sample. All right, I'm going to scroll through just to make sure I didn't make a silly button press somewhere. 69, 59. Okay, it looks good. So what I want to do is calculate one var, and the very tippy top there is my average, and the number of things in the sample is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is. All right, so let's go ahead and get to work. So I see that the average of this sample is 52.7333. The standard deviation that they want me to use is given in the problem. It's 8.9. Sample size was 9, and I want a confidence of 90%. So the ZC is of 90%, and so that would be 1.645. Okay, so that is the information that we can get or easily obtain. Next is the margin of error, which is going to be ZC sigma divided by the root of n. And so this is going to be 1.645 sigma divided by the root of n. Get to a calculator that I can actually use. So 4.8802. All right, so the confidence interval itself is going to be x bar minus e is less than mu is less than x bar plus e. So in this situation, x bar minus e is 47.8531. Then x bar plus e $57.6135. And that's your confidence interval. Okay, the next question is a hypothetical type question in which we have to just show hypothetical math. And so right now, our confidence is 90%. That's what we have right now, which gives us a ZC of 1.645. So they want to know what would happen if I made my confidence 80%. So if I made my confidence 80%, that makes it 1.28. So right here, ZC just got smaller. All right, so that's step number 1, is we identify and show that the ZC gets smaller. Now, what does the ZC have to do with anything? Well, where ZC is used is in the E formula. So we see that ZC sigma divided by the root of n. And so we just showed that ZC just got smaller. That's that's a multiplication number. So if I multiply by small, my answer gets small. Okay, so my E just got smaller in this situation. Okay, big whoop. How does that have to do with anything? Well, that means that directly affects the confidence interval. What I just showed is E just got smaller. So E's just got smaller. So if I add by a small number and subtract by a small number, this ultimately will get shorter. All right, so is this below average, average, or above average of 49? 49 is average. You see how 49 falls in between those two things. So 49 is average. So user confidence. So my answer is average. Because 49 is between the average limits. I'll say average limits. 47.8531 and 57.6135. Because it's in between those two. That's why. It's average. They feel safe, home, blah, blah, blah. We have an average claim paid is 3,750 with the standard deviation of 385.56. A sample of 422, and we want a confidence of 90%. So the ZC of 90% is 1.645. So we have a confidence of ZC of confidence of 90%, creating a ZC of 1.645. So that is used in the margin of error, which is ZC sigma divided by the root of n. So this is going to be 1.645 of sigma divided by the root of n. Okay, so we have our margin of error. And then we can go ahead to the confidence interval in which the question is asking. And so that's going to be X bar minus E and then X bar plus E. And this. All right, so that is the mu. Now we should probably get into S's. S's. So this is where we are going to start using the TC, the T table. S's. Okay, so sigma is not known. What makes the confidence interval longer? All right, so the formula that we do know is E is equal to TC S divided by the root of N. And we want, oops, excuse me, I don't want to start there. I want to start with a longer confidence interval. My bad. I'm sorry. Confidence interval. So if I want this to be longer, in essence, what I need these e's to be is larger. So e is equal to TCS divided by the root of n. So if I need this answer to be larger, how does n affect that? Well, I see that n is a division. N is a division. So it's going to be opposite. So if I want my answer to be larger, I have to divide by something that is smaller. And so of my two options, n is equal to 10 or n is equal to 21, the smaller of the two is n is equal to 10. That would have the smaller confidence interval. Okay, ooh, that was so nice of them. They give me the X bar so I don't have to plug and chug. So X bar in this situation is 132.70. Standard deviation, notice how it's an S of 3238. The sample size was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I want a confidence of 80%. So the first thing I do is I establish my degree of freedom, which is n minus 1, which is 9. Notice how n is still 10, though. And then I need a confidence of 80%. So this, because it's an S, we have to use the T table. And so here we had a degree of freedom of 9 and a confidence of 80%. Correct? Just want to make sure. Yeah, 80%. So the TC in this situation is 1.383. 1.383 is the TC in this situation. Okay, so now we have all the stuff, and now it's just following the formulas and plugging and chugging and stuff like that. So the margin of error is TCS divided by the root of n. Again, n is still the number 10, so don't accidentally plug in the number 9 for that. Right, so we have our error. And then our confidence interval is X bar minus E. Again, this is about averages. So X bar minus E. Then X bar plus E. Then again, one more problem, confidence interval. Here they give me the average. Standard deviation is an S. Sample size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Confidence is going to be 95%. My degree of freedom is 9. And thus my TC, so degree of freedom of 9 at 95%. Degree of freedom of 9 at 95%. 2.262. Okay. On to the E. plus our confidence interval. So the X bar minus E and then X bar plus E. Then last but not least, we're going to be talking about probabilities. How does decreasing the sample size affect the margin of error? So the margin of error is in question. In this case, it's ZC, which is going to be P hat Q hat divided by N square rooted. And so that means decreasing the sample size. That is N. So if I decrease this, if I make this smaller, I'll use the word decreases. If I decrease the sample size, how does that affect the margin of error? Notice how N is a division. It's a bottom number. So this is going to be an opposite. So this will increase. So how will it affect the margin of error? It will increase the margin of error. Again, arrows and things like that are necessary. Number 8, we see that a random sample of 512 judges, and we see that 279 of them were Democrats. So what that leads us to is the probability, which is R divided by N. So it's always the small divided by the big here. And so that is 5449. And then Q hat, which is 1 minus P hat, is 1 minus that. And that's 4551. All right, and then we want a confidence in this case of 99%. That will give me my ZC that I'm going to need. So again, we go to that little box. This one is of 99%. So 99% is 2.58. So 2.58 is ZC. Okay, so on to the E, which is ZC, P hat, Q hat, divided by N rooted. And so what I do is I begin with my P hat, Q hat, divided by N. It's going to be an incredibly small number, but we're just beginning. So that's where I begin. So I start with 5449 times 0.4551 divided by 512. Again, really small number. Okay, with that number, I square root that number. And then I multiply by 2.58 in this particular case. That's the margin of error. So thus the confidence interval, recall that this is probabilities. So you're going to be talking about P. There is no mu. It's a regular P. All right, so we take our P hat minus E. And our P hat plus E. Okay, next we give a brief interpretation of this. So we begin with our confidence. So in this problem is we're 99% confident that talk about the middle symbol. Is it a mu or is it a p? Say the words. So is it an average or a probability? This is a probability. We're 99% confident that the probability, not the average, but the probability all right. Next thing we do is we use context in a singular fashion. So don't use plurals, use singular. What are we talking about? So I believe we are talking about judges that are Democrats. So the context is a judge being a Democrat. Okay, and then give the confidence interval that you got. So the probability is between see my answer. And read it once. We're 99% confident that the probability of a judge being a Democrat is between 0.4881 and 0.6017. Yes, yeah. All right, and then this last question is asking about the minimal sample size. So we have a no preliminary estimate, a distance of 5%, and we need a confidence of 95%. So with a no preliminary, the minimal sample size is going to be 1/4 ZC divided by E squared. All right, so let's see here. We have a confidence of 95%. So what that is going to tell me is that the ZC, again, you take a look at that little box, is 1.96. And then we have a distance of 0.05, 5%. We have a distance of 0.05. So that means E is 0.05, 5%, 0.05. All right, so this is going to be 1/4 ZC divided by E squared. I begin with the inside, so 1.96 divided by 0.05 squared times 1/4, or AKA divide by 4. So the minimal sample size is 384.16. So 385. There it is.